solving quadratic equations by factoring when it's not equal to 0. So on 6.4, like I said, if you need to flip back in your notes and look at what we've talked about before, you can always do that. But in 6.4, we talked about solving quadratics by factoring, but the equations were already set equal to 0. So the only thing different today, and actually, give me a sec. I need to open this in a different version because this doesn't have the editing pens that I need. There we go. So now I've got my pens. Okay. So what we need to do is get it set equal to 0 first. So to do that, we need everything on one side of the equal sign and a 0 on the other side. So here, just this 35 needs to be subtracted over to the left because it's a positive 35. I'm going to subtract, okay, to move it over here. Now I'm going to write it out here to the side because I don't want to line it up under that x squared or that 2x because we're not combining those because none of those are like terms. So what you end up with is your x squared plus 2x minus 35 equals 0. Now that's where we started last week. Okay, it's already set up equal to 0. Now we factor. So this was the more basic type of factoring when your a value was equal to 1. Okay, so I'm going to off to the side here, I'm going to identify my a, b, and c. So a is the understood 1 here in front of the x squared, b is the 2 in front of the x, and c is the negative 35 that is the constant. So remember, when your a value is 1, you've got a quadratic trinomial. You are just asking yourself, you can set up the x method or box if you want, you're asking yourself what multiplies to negative 35 but adds to 2. Okay, it's what multiplies to your c value but adds to your b value. You can make a list of the factors if you need to. Okay, so you could come over here and say the factors of 35 could be 1 and negative 35, negative 1 and positive 35, and it could be 5 and negative 7, or negative 7 and positive 5. Can y'all think of any other things that multiply to give you 35? Do any of those that we listed combine to give us 2 when we add them together? Oh, and I just listed, I'm sorry, I listed negative 7 and positive 5 twice. I just switched the way it should be negative 5 and positive 7. That's my bad. And that's the one we're looking for because those are the ones that when I add negative 5 and 7, it would give me positive 2. So negative 5 and positive 7 are the two constants that are going to go in these binomials. And it's just x and x because a was a 1. So x squared just factors to x times x. Okay. Now that it's factored, remember we learned this last week. We said once you have it factored, you split and solve. So you set each factor equal to 0 individually and solve them. Because if either of those were to equal 0, the whole equation would equal 0. So over here, I would add 5 to both sides. And that would leave me with x is 5. And over here, I would subtract 7 from both sides, which would leave me with negative 7. And if you need to check your work, you can check these by going up here to the original equation and plugging them in. And if you plug them in and they make it true, they're solutions. Feel okay about those? All right, let's try number 2. Number 2 is going to be a little more complicated. I've got some larger values, but all of these have an x. So let's see what happens here. When I move this 18x squared, I'm going to move it by subtraction. And you don't have to show that every time. Most of you can do that in your head. So I've got what I started with on the left, and then I'm subtracting the 18x squared over to equal 0. None of those can combine because this x is to the fourth, this one is to the third, and this one is to the second. So they are not like terms, but they do have something in common. There is a GCF here, a greatest common factor, that can be divided out of all three of these terms. Okay, definitely x squared, because they all have at least an x squared. And then the number as well. 6 goes into 18, 6 does not go into 27, but 3 goes into all of these. All of these numbers can be divided by 3. So I'm going to factor out my GCF of 3x squared, and I'm going to put in parentheses what I'm left with once I do that dividing. So in the first term, 6 divided by 3 is 2, and then that would be x squared. And then 27 divided by 3 is 9. X cubed divided by x would just be x. And then negative 18 divided by 3 would be negative 6. And the x squareds completely reduce. Okay, so I've done that factoring. So that's going to make my factoring of this trinomial that much easier. What's in black is the trinomial. So I'm going to identify A, B, and C. A is the 2, B is the 9, and C is the negative 6. So this time when I do this, remember, A is not 1 anymore. So I have to do A times C to get what goes in the top. So 2 times negative 6 is negative 12, and B goes in the bottom. That's 9. So I'm looking for what multiplies to negative 12, but adds to 9. So again, you can list your factors of negative 12 to the side if you need to. That could be 1 and negative 12, negative 1 and positive 12. Could be 2 and negative 6, negative 2 and positive 6, or it could be 3 and negative 4, or negative 3 and positive 4. So we're looking to see if any of these would combine to 9. It doesn't look like any of those would combine to give me 9. That would be 10. That would be 4. That would be 1. Okay, so I don't think I missed any factors of 12. So that means that this part is not factorable. Okay, so this one I cannot solve by factoring because this part right here is not factorable. Okay, so that means I can't go any further. I'm not going to ask you to take this any further. That means that the zeros, the x-intercepts, which is what the solutions represent graphically, would be decimal values that you can't find by factoring. Okay, so we can't do that because none of those factors of negative 12 add to 9. Okay, let's move to the next one. Okay, here I'm going to move that 120 over here to the other side by subtracting it. And then this has a GCF also. All of these are also divisible by 3. So I'm going to take out my GCF of 3. This time they don't all have an x term though, so just 3, not any x. So that's going to leave me with x squared, because those 3's will reduce. That will leave me with negative 3x, and that will leave me with negative 40. Okay, so I'm going to do the same thing I did on the last one, and this new GCF that I'm left with right here, I'm going to identify A, B, and C and try to factor this. Now this time my A is an understood 1, which makes factoring easier. So it's just C and B I'm worried about. What multiplies to negative 40 but adds to negative 3? So you can again list your factors. So it could be 1 and -40, -1 and +40, could be 2 and 20, could be 4 and 10, could be 8 and 5. And that's it right there. It's the 8 and the 5 that would combine. We want them to add to -3. 5 and -8 would add to -3. So when I factor the trinomial, the two numbers that I just came up with are +5 and -3. And then I don't forget that I still had that GCF of 3 outside and that 0 there. And that GCF, since it does not have an X in the term, it really doesn't matter. Because if I divided that 3 over, what's 0 divided by anything? Still 0. So a constant that is a GCF doesn't affect what we're about to do. Okay, had there been an X there, that would be part of what we're splitting and solving. Okay, and if you want to leave it so you can actually see it divides over as 0, we can leave it in front there, if that'll make more sense. So over here, I would add the 3 to both sides and get 3. And over here, I would divide that 3, which would still leave me with 0. And then I would subtract the 5, which would give me -5. So those are my two solutions. Remember, these are representing x-intercepts of the graph when you were to graph the quadratic. Okay, in this next one, I would move the 2x and the 8 over here by subtraction. So it'd be -2x minus 8 equals 0. There is no GCF to factor out, so I'm ready to do my ACB table or my X. We're do A times C. Let's identify A, B, and C. I didn't do that yet. So A is 3, B is -2, and C is -8. So A times 3, 3 times -8 is -24, and B is -2. We're asking ourselves what multiplies to -24 but adds to -2. Out of here. Okay, so you can list your factors. Okay, of -24 again. So that could be 2 and 12. 1 and 24, obviously, or 2 and 12, or it could be 3 and 8. Or it could be 4 and 6. Not divisible by 5, and then we're back to the 6. So those are the factors. We want to know which combination of those add to -2. And that would be 4 and -6. So that means that this trinomial, oops, A was not 1, so this is going to look a little different. In this trinomial, I'm going to replace that middle term, okay, and I'm going to use the 4 and -6. So +4 and -6 are going to replace this -2. So +4x and -6x. That's the substitution that I'm doing here in the equation. The rest of it is going to stay the same. There's going to be that -8 and that 3x squared. Now I do grouping. This is the ones when A is not 1 and I have to do this method. I factor by grouping, which means I split the two terms on the left and the two terms on the right. So in this on the left, I look for a GCF. What can both of these be divided by? And that's x, which will leave me with 3x plus 4. And then I do the same thing on the right. Okay, I can divide both of these by negative 2, which would leave me with 3x plus 4. And that is the point when we do this, that both of these come out the same. So 3x minus 4 is a factor. And we bring together those GCFs, x and minus 2, as our other factor. And this is all still equal to 0. Now we're ready to split and solve. And we set each factor equal to 0. And this one we would just add the 2 over. We have our solution. This one we would add the 4 over, but there's still a 3 in front of the x that we would have to divide out. So we would be left with 4/3. So those would have been my 2 solutions. All right, last couple are not trinomials. So these will be a little easier. This is taking it back to what we were doing before. I still need to move that 49 over by subtraction to get this set equal to 0. But now this time it's a difference of 2 squares. So this is the one that had the shortcut where I'm simply taking the square root of the 2 terms. So the square root of this one is going to go here and here at the start of those binomials. And the square root of this term is going to go at the end of both of those binomials. So the square root of 16x squared is 4x. And the square root of 49 is 7. Who remembers what the only difference is supposed to be between these two binomials? We're doing this difference of 2 squares type of factoring. What was the only difference? They're both going to be 4x and 7, but what's in between them is different. One gets a plus, one gets a minus. That's the only difference. Now this is still set equal to 0, and now I'm ready to split and solve. So 4x plus 7 equal to 0, and 4x minus 7 equal to 0. So over here, I would add the 7 and divide by the 4. And I get positive 7/4. Over here, I have to subtract the 7 to move it. And then divide by the 4. So I get negative 7/4. So nearly identical answers, just one is positive and one is negative. Okay, let's try that for this last one. I'm going to subtract that 48 over. Now this time, when I look at this, these are not perfect squares. I can't take the square root of 3. I can't take the square root of 48. Okay, so this is not difference of 2 squares because I can't take the square roots. So alternately, though, I can take out a GCF. They can both be divided by 3, and let's see if that changes it. So if I divide out a 3, that would leave me with x squared for that first term because the 3's would reduce. And 48 divided by 3 is 16, so that'd be minus 16. Well, how about that? Now that is a difference of squares. Okay, so now I can factor that. All right, y'all have a good lunch. I'm going to finish this example for the video. So now I take the square root of the x squared, which is just x, and the square root of the 16, which is 4, and I get one positive and one negative. And now I'm ready to solve. Okay. I guess I should add up here. It's not difference of squares yet. Okay, but when I took out the GCF, then remember GCF stands for greatest common factor, then it became a difference of 2 squares. So to split and solve, I would set the x minus 4 equals to 0 and add the 4 over. I get positive 4. Over here, you can ignore this 3, or you can do like I did in that previous problem. If you need to see it divided over and that it doesn't change anything, we can show that. So it's still just x plus 4 equals 0. And I would subtract that 4 over. So I get positive 4 and I get negative 4 as my 2 solutions. Okay, so that's what we're going to be practicing today. It's the same thing we did last week on Thursday in 6.4, except this time they were not set equal to 0 yet. We had that extra step at the beginning.